Okay. Well, we actually get to start talking about trig ratios here. Now, we have talked about really only one general definition that's new to us, and that is defining what a radian measure is, where it's relating the ratio of the arc length to the radius. So we're going to be looking at some other ratios within a right triangle. And I'm going to write the ratios down over here on the side, just so you can see how they're spelled. And you're probably rarely going to see these actually spelled out for the rest of the course. Sine is S-I-N-E, cosine, and tangent. Those are the three ratios that we're going to be talking about most often. But our other three basic ratios are called cosecant, secant, and cotangent. And if a couple of those words look familiar, tangent and secant, they kind of look familiar from high school geometry. There's a reason for that. So geometrically, they mean something, but we're not going to talk about that right yet. We're just looking at these ratios in terms of this right triangle. So we're going to look at the first ratio is sine, and we abbreviate it S-I-N, sine theta. So when I'm looking at this angle, and I want to talk about the ratio of the opposite side to the hypotenuse, right? That's going to be my sine theta. In this case, it's A over C. And I abbreviated here. You're going to be able to abbreviate on your test, opposite over hypotenuse. Cosine theta is the ratio of the adjacent side to the hypotenuse. So it is B over C. Tangent theta is opposite side over the adjacent side, which is A over B. Now, if you look over here underneath my right triangle, you see these letters here, all in capital letters, and it may not make sense, but it was really just abbreviation for this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And a lot of students like that acronym, SOHCAHTOA. And there's acronyms that you could come up with to help you remember that if you need to. It's not something that I learned in high school trigonometry, so it's not something that I use. But if y'all want to use that, that's fine. Okay, so sine, cosine, tangent. Those are my first three basic trig functions that I'm going to use most of the time. But then I also have these other three functions, cosecant, secant, and cotangent. So cosecant theta is defined as the ratio of the hypotenuse over the opposite side, right? So C over A. Secant theta is defined as the hypotenuse over the adjacent side, C over B, and cotangent theta is defined as the adjacent side over the hypotenuse, over the opposite side. Adjacent over opposite is B over A. Let me see if I can zoom in here just a little bit. One of the things that I want you to notice is that these two are reciprocals. This is A over C, C over A, B over C, C over B, A over B, B over A. So when I write problems with using all of those 6 trig functions, I'm going to try my best to always organize my work just like this. Sine, cosine, tangent, cosecant, secant, cotangent. That way you're able to see these are reciprocals, these two are reciprocals, these two are reciprocals. And we're going to be talking more about that as we go here. Okay, problem 1 says to use the Pythagorean theorem to find the length of the missing side of the right triangle, then find the value of each of the trigonometric functions of theta. Okay, so Pythagorean theorem, a squared plus b squared equals c squared. So 20 squared plus 21 squared equals c squared. 20 squared plus 21 squared is 841. Take the square root of that, and you get 29. Now, again, I want to mention that normally when we take the square root, we want positive and negative answer here. But because my C is representing the length of the side of a triangle, I know it has to be positive. So it's going to be positive 29. There are going to be some problems that we're going to do later on in the course where you do have to be sure that you include both the positive and the negative. So be sure you know when you need to include it and when you don't. In this case, I don't. So this is 29. So now I can use these definitions to find sine, cosine, and tangent. Right? So sine theta is opposite over hypotenuse. So the opposite side is 20, hypotenuse is 29. So this would be 20 over 29. Cosine theta is 21 over 29. What did y'all get for tan theta? Okay. And cosecant. Whoops, I forgot my theta. That's like one of the cardinal sins. There you go. Secant theta. Okay. And cotangent. 21. Okay, now, does anybody have any questions on this? Some of your homework problems, you're going to be given a leg and a hypotenuse, and you have to solve for one of the legs. I don't have an example like that, but I can do an example like that real quick if you needed me to. Does everybody know how to solve for a missing side here? Okay. If you have questions, come see me and I will help you with it. Again, with my marker. All right, the next page. Let's go down here. We have two special right triangles, an isosceles right triangle. No, isosceles triangles have two sides that are the same measure. So they're going to have two angles that have the same measure as well. So 45, 45, 90. And then we also have a 30, 60, 90 triangle. For those of you who had high school geometry, y'all probably remember those two special types of triangles showing up quite a bit. And your book does, your trigonometry book does a pretty good job of explaining where these side links come from. Now, it's really kind of beyond what we need to do in this course. We're just going to say that we're taking this for granted. Somebody somewhere already proved that in geometry, and we're going to assume that we know how they proved it, and we're just going to take it and run from there. Okay. So these two types of triangles we're going to use a lot in this course, not just in this chapter, but throughout the whole course. So we're going to look at sine, cosine, and tangent, cosecant, secant, and cotangent of each of these three angle measures, 30, 60, and 45. Okay. So 30 degrees is up here. Sine is excuse me, opposite over hypotenuse. So my sine of 30 degrees is 1/2. And notice that my 30-degree angle, I also have it written as radians. That's pi/6. My suggestion to you is that you memorize that because you're going to use it a lot. Cosine of 30 degrees is adjacent over hypotenuse. So that's square root of 3/2. And tangent is opposite over adjacent. Let me zoom in here. Now I'm going to write this to the left of my little box. 1/3 the square root of 3. Because now I need to rationalize my denominator. So I need to multiply numerator and denominator by square root of 3. And that's going to give me the square root of 3/3. Does anybody have any questions about how I rationalize my denominator? Okay, so from now on, I'm not going to show how I rationalize my denominator. I'm just going to go straight from here to here. Okay. All right, cosecant is hypotenuse over opposite, right? That's what my definition here was, hypotenuse over opposite. So 2/1 is 2. How much time we have? 5 minutes. Okay. I want to mention this just because I think that it's something that y'all need to be thinking about as we go through this course, especially with this first chapter. When I was figuring out cosecant, in my mind, what I did was I figured out sine and then just flipped it upside down. So I know that sine is opposite over hypotenuse, and I just flipped it down, upside down, hypotenuse over opposite. So I say that to say this. I would not take the time to memorize this. I would just know that this is this stuff upside down. So you just have to memorize 3 of them, 3 ratios, and then over here, you just need to know what order they go in and flip them upside down. So you need to be sure that you're relating sine and cosecant. You're relating cosine and secant and tan and cotan. Does that make sense? Okay. Trying to help y'all make some shortcuts here. All right, so secant of 30 degrees is going to be hypotenuse over adjacent. So 2 over the square root of 3. When I rationalize my denominator, that's 2 times the square root of 3 over 3. And cotangent is adjacent over opposite. So square root of 3 over 1, which is just square root of 3. And let's do sine of 45 degrees with pi over 4. Sine is opposite over hypotenuse. So 1 over the square root of 2. And that rationalizes to square root of 2 over 2. Cosine is adjacent over hypotenuse, 1 over square root of 2. So same thing, right? Square root of 2 over 2. Tangent is opposite over adjacent, so 1 over 1. And I'm not going to do the rest of that column here. Let's look at sine of 60 degrees. The sine of 60 degrees is opposite over hypotenuse, so square root of 3 over 2. Cosine adjacent over hypotenuse, 1 over 2. And tangent opposite over adjacent, so square root of 3 over 1, which is square root of 3. Now, I'm not going to worry about doing this bottom part here. I want us to talk about the relationships between sine, cosine, and tangent of 30 degrees, sine, cosine, and tangent of 60 degrees next week when we meet. Evaluate without a calculator. I do want to mention that on your homework, there will either be in the instructions or a pop-up with an instructor tip that tells you when you can or cannot use your calculator. So pay close attention to the instructions, because on your test, there's going to be some problems that you're not going to be allowed to use calculator for. So you need to be sure that you're practicing like you're going to be testing. Right? All right, so problem 3, sine of pi over 4. What I'm going to do is just go back to this table that I just did here. Now, if you needed to go back and start from scratch to do this problem, that's okay. But sine of pi over 4 is square root of 2 over 2. Cosine is square root of 2 over 2. That's 0. Okay, before we go farther, I actually want to go back just real quick to these definitions. Where we said sine is opposite over hypotenuse and cosecant is hypotenuse over opposite, those were our definitions of all of these functions here. But what you should notice is that these are just reciprocals of each other. That's where the next page of our handout comes into play with what's called reciprocal identities. Sine is 1 over cosecant, or cosecant is 1 over sine. Cosine is 1 over secant, secant is 1 over cosine, and you can see the tangent here. a while ago, last week, when we were talking about our 6 trig functions, I told you I was going to try to do my best to always organize my work where I have sine, cosine, and tangent on the left, cosecant, secant, and cotangent on the right. And the reason why I like to organize my work that way is because it makes computation a little bit easier for me, makes me have a little bit easier way to double check my work, right? These are just reciprocals. And another thing that we could work through is what's called quotient identities. If I were to take, going back here, this definition of sine and this definition of cosine and divide that, A over C divided by B over C, the C's cancel out and I'm left with A over B, which is tangent. So tangent is sine over cosine. So these are my reciprocal identities and my quotient identities that I'm going to be using to solve some problems here. Okay, so problem 4. I normally prove these things. I'm just going to skip my proof this time. Okay. I know that tangent is sine over cosine, according to this definition. So sine over cosine. So 5/6 over square root of 11/6. Okay. So if I multiply both the numerator and denominator by 6, I can get rid of those complex fractions. That means my 6's are going to cancel out here and here. So I end up with 5 over the square root of 11. And then I just need to rationalize my denominator. And that's going to give me 5 times the square root of 11 over 11. If you're not sure how I rationalize my denominator to get from here to here, then come see me and I will help you with that. Okay, so the second part on the right-hand side, I can go back to my definitions if I want to, but I don't need to. I know that they're reciprocals, right? So according to these reciprocal identities, these things are reciprocal. So just flip it upside down. That's 6/5. This is going to be 6 over the square root of 11. Rationalize my denominator. I get 6 times the square root of 11 over 11. Here I flip this upside down. Now, I think this is interesting. I don't want to take this and flip it upside down, because if I do, that square root would be in the denominator. I'm going to go back to this and flip it upside down. And that just gives me square root of 11 over 5. So I save myself a little bit of work there if I'm going from here to here. Any questions with that? Okay, the next problem says to use an identity to find these values without using a calculator. Again, I know that sine and cosecant are reciprocals, so I need to get either both of these to be sine or both of these to be in terms of cosecant. And I'm going to put both of them in terms of sine. I'm going to leave sine 99 degrees like it is. And I'm going to rewrite cosecant as 1 over sine of 9 degrees. Right? So I'm just taking this definition right here. Cosecant and writing it as 1 over sine. So if you want to, you can make that first term to be a fraction, so you can easily see what you have in the numerator and what you have in the denominator. They cancel, and you just get 1 for your answer.